Hey, good day. Today we're going to discuss part 5 of matrix algebra, and we are going to cover the topic determinants. The determinant of the matrix is denoted by the first three letters, a DET, and its matrix name. The determinant is simply a scalar value or a number that is calculated using a square matrix. So a determinant can be solved if you only have a square matrix. So it's applicable to a 2 by 2, a 3 by 3, a 4 by 4 matrix, or any larger square matrix. So this is used to characterize invertible matrices, or those matrices that can be inverted. So there are different methods of finding the determinants. This would include the Sarus rule, the Laplace expansion, the pivotal element method, and many more. So for this video, we'll be discussing the three methods. So under determinant matrix, we have what we call the minor matrix or the sub-matrix. So this is formed by deleting one row and one column from some larger square matrix. The minor matrix will be named after the row and column deleted. So the minor matrix is the same with the cofactor, except that cofactors are preceded by either positive or a negative sign, which is taken from the formula -1 raised to the sum of the column and row number. So let's review. So given matrix A with the following elements. So the minor matrix for, let's say, element G, which is element A3, 1, will now be taken as, by deleting your column and your row, it will now be equivalent to B, C, E, and F, which is the remaining value. And the determinant of the minor matrix is simply equated as B times F minus C times E. For the determinant of a matrix under Sarus rule, this will now be applicable for a 3 by 3 matrix or a smaller matrix. So the determinant is simply defined as the sum of the products along the downright diagonal minus the sum of the products along the upright diagonal. So this is the same as our basket rule. So if we have here, let's see, matrix A, which is a 2 by 2 matrix. So its determinant now is computed by the downward product AB minus the upward product, which is BC. Okay? So we have here matrix B, which is a 3 by 3 matrix. So its determinant will simply be the sum of the products of the downright diagonals minus the upward products. So you can do this by simply copying the first two columns on the right side. Okay, or you can do this by basket method. So C times B, BF times G. So another method to solve the determinant of a matrix is the Laplace expansion, which is also called as the cofactor expansion, as we are going to use in our equation or in our computation the cofactor of the element. So the Laplace expansion would now express the determinant of any square matrix simply as a weighted sum of its minors. So in Laplace expansion, we're going to use the equation, the summation of the products of the cofactor and its equivalent element. So in this equation, Aij will simply be the element in the ith row and the jth column. Your Mij is the minor of the matrix. And the negative 1 raised to I plus j times the minor is our cofactor of the element ij in the matrix A. Another method that we use for determinants would be the pivotal element method. So this is almost the same principle as the Laplace expansion by taking out the row and the column, except that instead of eliminating the rows and columns of a specific element, we are now going to eliminate or remove the rows and columns of a pivot element in order to form a n-1 by n-1 matrix. And this pivot element should be equal to 1 in the matrix as chosen. So if no unity element or no element is equal to 1 is present in our matrix, then we can choose any convenient element that can be reduced or simplified to 1. So to understand the different methods of computing the determinants of matrices, let us solve some examples. So we have number 17. We are given matrix Q with the following elements. So this is a 3 by 3 matrix. So for matrix Q, we can apply Saru's rule. So we will simply be copying the first two columns on the right side. So for the determinant Q, that will simply be the sum of the products of the downward elements minus the sum of the products of the upward elements. So for our downward right element, we'll have 1 times 4 times 6, which is equal now to 24. Next, we have 2, 5, 1, that's equal now to 10. And we have 3, 0, 0, so that's equal to 0. So subtract that to the upward diagonal. We have 1 times 4 times 3. That will now be minus the quantity 12 plus 0 times 5 times 1. So that's 0. And then we have 6 times 0 times 2. That's 0. So completing now our equation, the determinant of matrix Q is equal to 34 minus 12, giving us an answer of 22. So the determinant of matrix Q is equal to 22. Okay? So let's solve another matrix. We have matrix Y, which is again a 3 by 3 matrix. So we could still apply Saru's rule. So copy the first two columns. So we have our determinant of Y is simply equal to our downward elements. So 1 times 4 times 3 is 12. Then we have 2, 5, and 1. So that's 10. Then we have 3, 2, and 2. So that is 12. So minus upward diagonal. So we have 1, 4, 3. That's 12. 2, 5, 1 is 10. 3, 2, 2 is 12. So simplifying, we'll have now the determinant of y is equal to 34 minus 34, wherein determinant of y now is equal to 0. Okay, so let's solve another example. For the given matrix Q, let us solve the determinants. So we are given now a 4 by 4 matrix, so we cannot apply the Sarus rule. So in here, we're now applying the Laplace expansion. So in Laplace expansion, we can choose any element and apply our cofactors and multiply it to the equivalent element in a row or in a column. So what I will do, the solution is to choose the first element along the first row. Okay, so the usual solution for Laplace is choosing the element E11 and considering either the column or the row. So in this, we'll be considering the first row or element E11. So we'll now apply multiply it to its corresponding minor matrix. So we now have K11 or element 11 multiplied to the cofactor. So that will now be equivalent to 4 times the minor matrix. The sign convention for the cofactor for the first element is plus. So by applying now, so we have now here a 3 by 3 matrix, so we could apply the Sarus rule for the minor matrix. So we'll now have 4 times 28 minus 192. Simplifying this, we now arrive at negative 656. Okay? And then we move to the second element of the first row. So that will now be E12 multiplied to its cofactor. So that will now be 2 plus its cofactor. So 2 times negative of the minor matrix. So solving this now by Sarus rule, we'll now have 2 times negative 659 minus 85 times 2, where that is equal to negative 114. And then we now use or solve for the next element 5, which is E13. So multiply it to its minor matrix or its cofactor. So that will now be E13 times C13. So that will now be equal to 5 times cofactor of 5 is positive times the minor matrix. So that will now be equal to 5 times positive 160 minus 84. And that's equal to 380. And then lastly, we have K12 times or K14 times C14 is equal now to 6 times its cofactor, which is negative, times the minor matrix, which is equal to 6 times negative 42 minus 666, or this will give us a value of 3744. So once you have computed for all of the products of the element and its cofactor for that row, we now simply add them up. So negative 656 plus negative 1144 plus 380 plus 3744, it will give us a determinant of K, which is equal to 2324. Okay? So as a practice, you can now try solving the determinant by using the other rows and columns. You will get the same answer as well. So how will you do that? You can take still the first element, so we'll now be considering the column instead. So what you will have is K11, K1, or K21, K22, or K21, K22, K23, and K24. Tapos, consider its equivalent cofactors. So once you have solved it, you have to be able to get the same value of 2, 3, 2, 4. Okay? So let's solve another example. So another example, we have example number 20. So we have matrix F, which is also a 4 by 4 matrix. So in here, we could still apply the Laplace expansion. So I'll just show you how to use the Laplace expansion if we're going to consider another element, and instead of a row, we'll be applying or considering a column. So let's consider this element, which is element 1, 2. And we'll be considering its column. So in here, we'll now be solving the products of the element 1, 2 times its cofactor. And then the second that we are going to solve is 2, 2, 3, 2, and 4, 2. Okay? So what we'll do is to consider our minor matrices for each element. So for the first element, 1, 2, its minor matrix will be the highlighted or enclosed numbers. So F12 will now be 3 multiplied to 3, 1, 3. So its minor matrix. That will now be equivalent to 3 times negative, or that's times, yes, it's equal to negative 5 minus 9, giving us a value of 12. Okay? And then F22, it will now be 2 times its equivalent cofactor. So that's equal now to 2 times positive quantity of 7 minus 5, which is equal to 4. Then we have 3, 2. So it's 0 times its cofactor, which is equal to 0 times negative quantity 12 minus 7. So it's equal to 0. And for 4, 2, that will now be 2 times its equivalent cofactor, which is 2, 3, 1, 3, 1, 3, and 1, 1, 2, which is equal now to 2 times positive 16 minus 25. So you know how to get its equivalent minor matrix. Okay, the method. So for your cofactor, don't forget your sign convention. So sa C12, that will now be, so kung positive lagi yung A11, so A12 is negative. So this is negative, positive, negative, positive. Okay? So if I'm going to consider row, let's say row 2, column 1, then if I'm going to consider the column, then the sign convention will be plus, minus, plus, minus. So same principle lang. Usual mistake for Laplace expansion is forgetting the sign convention for the cofactor or using the different sign convention. Okay? So let's move. So for the determinant of F, just simply add the products of the element and its cofactor. So in here, we'll now get the value of the determinant of F as equal to negative 2. So again, it's practice problem. Try solving the determinant using the other rows and columns. You should also get the same value. Okay. So let's solve example number 21. So let's solve the previous problem number 19 by pivotal element. So we have matrix A, which is a 4 by 4 matrix. So what we will do for pivotal element is to choose any element that is equal to 1. So we have three options. Okay, so we have 4, 1, 4, 4, and 1. So to have it simple, let's choose element down the row 4. So we have two options here. So let's choose 1 or 4, 1. Okay. So what we'll do is to eliminate its row and its column. So what we will do is to solve for the determinant K using -1 raised to the sum of the row and the column. So that's 4 plus 1. So it's the same as the K factor. Negative for the sign convention. And then what I will do is to simply write our minor matrix of the pivotal element. So we'll have now 2, 3, 0, 5, 1, 3, 6, 8, 2. And then for each of the element in the minor matrix, I'll be multiplying this to the, or I will be subtracting the product of the elements that would intersect the element. So for 2, it will have 4 and 2. Okay, so that will be minus 4 times 2. So next element, we have 8. That's 3 times 2. So saan nanggaling si 3 times 2? So this is element 8. Its intersection is 3 and 2. And for 0, its intersection will be 9 and 2. So 0 minus 9 times 2. Then for 5, that will now be intersection will be 4 and 9. So minus 4 times 9. So for 1, that will be 3 and 9. So minus 3 times 9. And for 3, that will be 9 times 9. So 3 minus 9 times 9. Then for 6, that will be 4 times 1. 8 is 3 and 1. So 8 minus 3 times 1. And then for 2, that will be 9 and 1. So that's 2 minus 9 times 1. So before we continue, notice first the pattern that we have for the values that we are subtracting to the elements in the minor matrix. So as you can see, we have 4, 4, 4. So on the first row, it will be multiplied to the element on the first row of the eliminated column. So ito 3, 3, 3. That's 3. 9, 9, 9. That is 9. Okay? And then for the first column, it is multiplied to, or the product is taken from the value of the column that is where we can see the element. So 280, lahat sila, it's multiplied to the element that coincides with on the row that is eliminated. So we have 291. So we have 291, 291, 291. Okay? So that's how to check. So let's simplify now, okay? So we'll have negative 1 raised to 4 plus 1. That will now be a negative value. So simplify the values of the elements. So 4 by 4, this becomes a 3 by 3 matrix. So we'll have now 2 minus 8, that's negative 6. 8 minus 6, that's 2. 0 minus 18 is negative 18. So next column, we have 5 minus 36, so it's 31. 1 minus 27, that's negative 26. 3 minus 81, that's negative 17. Then for the last column, we have 6 minus 4, that's 2. 8 minus 3, that's 5. And 2 minus 9, that's negative 7. Okay? So for here, we could now simply apply our Saru's rule. Pero to see what happens if we have a matrix that do not have a pivotal element equal to 1, I will solve again for the equivalent n minus 1 matrix using this one. Okay? So let's choose now. So this is our first solution for the pivotal element. So let's choose the smallest number. So we have positive 2. So what I will do here is to factor out 2 in the matrix. So I will now have negative. So we have negative, this value. So multiply it to negative 1 raised to the position of the pivotal element that we will choose. So this is 1 plus 3. So factor out 2. So what will happen on the first row? So negative 6 divided by, or before that we write our minor matrix first of the pivotal element. So we'll have negative 2, negative 18, negative 26, and negative 17. So again, we subtract this to the product of the elements that would be intersecting our element. So 2 is negative 6 and 5. But take note, yung 2, yung negative 6 is in the same row as our pivotal element, and we have factored the pivotal element. So magiging negative 6 divided by 2 na siya. Okay, multiplied to 5. Then for 18, that will be negative 7 multiplied to negative 6 divided by 2. So let's move to the next element. So that is negative 26 multiplied to 5 times. Ito will now become negative 31 divided by 2. And then for negative 78, this will now become negative 7 times negative 31 times 2. So let's simplify. So P now is, so negative 1 raised to 4 is positive multiplied to negative, so it's still negative. So simplify. 2 minus the quantity 5 times negative 6 divided by 2. Pag ilalagay ko na siya dito sa matrix na to, if multiply ko siya sa 2 or doon sa na-factor out na value. So that will now be equal to 34. And then we have the next one, negative 39. So negative 18 minus negative 7 times negative 6 divided by 2. So ang makuha dito is negative 39. I will not be multiplying it to 2 anymore kasi hindi ko naman finactor out yung ating value. So let's continue. So we'll have negative 26 times 5 times negative 31 divided by 2. Multiply the first row with the factored element, pivotal element, so that will now be equal to 103. Then for the last element, it's negative 78 minus negative 7 times negative 31 over 2. Then we get negative 373 divided by 2. So again, what we will only be multiplying to the factored pivotal element is the first row. Okay? So with that, we'll now have to apply Saru's rule now. So 34 times negative 373 divided by 2 minus negative 39 times 103. So we will get a negative value of negative 2324. So negative times negative will arrive at 2324. So again, you can try solving the determinant using another pivotal element. You should get the same answer. Okay? So if we're going to check also, what we have solved using the pivotal element is the same with what we have solved with the Laplace method.